In the following example, I'm going to show a web server that I wrote using the Python Flask web framework. It uses the basic HTTP realm to authenticate the user. What we'll do is to create a local database containing the user credential before we fire up the web server. The script I wrote is called http_server.py, and it contains two objects, the database and the user object. What we will do is fire up the Python interpreter by typing in Python. And I'm going to type from http server import db, user. And I'm going to use db.createAll to create the database. I will create a user by using u equals user with username equals to Eric. And the user has a method of set password. What I'll do is use u.set_password with the value of secret will set the password. I'm going to add the user by using db.session.add, and I'm going to commit the session by using db.session commit. Now I have created a database to authenticate a user against called network.db. Let's fire up the HTTP server, python http server.py. As you could see, this server is running on the local host at 0.0.0.0 at the 5000 port. This means it's binded to all the IP address locally. I'm using iTurn. I'm going to open up another tab on the same host and use the HTTP to get the device's API endpoint on the same host. HTTP get HTTP 0.0.0.0 port 5000 and the device's endpoint. As you can see, I get an HTTP response of 401 unauthorized back. This means the authentication is required. You could see in the authenticate header in the basic realm that it stated authentication required. So let's do that. Let's supply the username and password that we created. http://auth Eric secret. And let's go ahead and use the same API endpoint of http 0.0.0.0 5000 and devices endpoint. As you could see, now we have an HTTP 200 OK message, meaning it was successfully authenticated. Let's go back to the web server and take a look. In the first request, the web server returned a 401 authentication error because it didn't have the basic authentication. On the second request, it returned 200 OK because you supplied the correct authentication credential. In the next example, we're going to use the Postman with API key to authenticate ourselves against the Meraki cloud-based controller. The Postman software could be downloaded at postman.com/downloads. For the Meraki controller, let's leverage the developer.cisco.com DevNet sandbox. You can log on to the website and choose the sandbox icon, which will direct you to different tracks. Let's select the networking track. In the networking track, we'll find a Meraki always-on sandbox, which we could select. Once selected, we will see all the credentials needed to access the Meraki controller. Also, under the Meraki Learning Lab track, we could download the necessary Postman collection as well as environmental variable. Let's take a look at the Postman. In the collection of Meraki Dashboard API, we could select the admin list the dashboard. On this URI, we will have the organization ID that is provided by the environmental variable, in this case, 681155. We will also have the header of a x-cisco-meraki-api-key. In this case, is also provided by the environmental variable. Note that this might change by the time you watch this video. Let's click on Send. It's sending the request toward the Meraki controller, and it's getting back the current results of all the organizations. Let's try a different way. Let's uncheck this box so that the subsequent request will not have this API authentication key. Let's see what happens. If we click on sending, you'll get a 404 error of not found because it's not authenticated. There you have it. That is the example of using a static key to authenticate ourselves against the Meraki cloud-based controller. In the next example, let's use a session-based dynamic API key to authenticate ourselves against a Cisco APIC-EM controller. I have written a script called the APIC-EM example.py. Let's take a look. In line 9, it's the start of a getTicket function. In line 7, we will see the controller, that is the Cisco Sandbox APIC-EM controller. Starting from line 9, we'll have a getTicket function that specifies the URL on the controller/API v1 ticket. We will use the payload specifying line 14 of username and password. At the end, we will receive a ticket that is session-based from this function. Starting from line 31, we will use that ticket, call another API endpoint, which is /API/v1/network-devices. What this would do is to authenticate ourselves as well as get the list of network devices registered to the APIC-EM controller. Once we get the device list, we will print the route format, start with network devices. Then we'll iterate through each of the devices and print out the ID as well as the series. Toward the end of the script, you could see from line 54 that will get the ticket and line 55 that will get the network devices. Let's clear the screen, fire up the Python interpreter, and execute that script. Wow, that is a lot of output. Let's scroll up and look at the network devices in the route format. As you can see, we have the network devices in a dictionary format. Let's scroll all the way down to see the pretty print format at the end, where we have the ID as well as the series. So that is an example of using a dynamic session-based key to authenticate ourselves against a Cisco APIC-EM controller.